the President and CEO of Nautel, Mr. Kevin Rogers.
Welcome to our virtual NUG, everyone. Like many of you, I can't remember an April without Las Vegas, and that has included attending our NUG event on Sunday morning prior to NAB. If you have joined us for this event in the past, today's VNUG will be a compressed version of what you're used to. If you haven't been able to attend a NUG event in Las Vegas, today we'll give you a sample of what our NUG event is all about. In the interest of time, I'll hand it over to Jeff Welton now. Enjoy, stay well, and I hope to see you all in person next year.
Thanks very much, Kevin. It's a really interesting time. First off, I want to thank everybody for giving up some of their day to come visit with us today. We had nearly 1,000 registrations for this, and we're over half of you are online already. So we've already broken every record for NUG attendance. Maybe that whole Vegas thing was a lot harder than it looked. We've got a lot of stuff to cover today. We've only got an hour, so we're probably going to go a little over. If you have to drop off, this will be archived. Don't worry about it. We'll handle questions as we can. We're going to start off, and the one thing I'm really going to miss about Vegas this year is the virtual t-shirt cannon, but we're going to start off with Mr. Paul McLane from Radio World. Paul?
Jeff, thank you. Yes, I couldn't figure out how to distribute t-shirts virtually, so we'll have to wait for next year. But it's a joy to be asked by Nautel to return and say a few words each year about stories that I'm keeping an eye on. This year's event might be virtual, but it's an honor, a real honor anyway. So thank you to our Nautel friends. You know, at Radio World, the coronavirus threw us a giant curveball just like everyone else. And on our end of things, we're working from home and scrambling to cover a new set of stories. We had to quickly rethink the content of our pre-NAB show issues, and we put together a series of webcasts to explore how various broadcasters have built new workflows over the past several weeks. Because, of course, you don't need me to tell you, the biggest story of the year for radio is how our industry reacted. Holy cow, this photo says it. That's Debbie Feinstein of WTOP here in Washington. She posted about how she never thought she'd be anchoring major market news from her closet. But we've seen a lot of pictures like this over the last few weeks. The radio industry has learned in a very compressed amount of time just how efficiently it can operate remotely. Client remotes getting canceled, sports broadcasts canceled, promotions canceled, salespeople couldn't get clients on the phone. Suddenly, radio engineers had to rush out and buy iPads to equip people in the field and teach staff how to voice track and import audio. And you, if you're watching this NUG, you had to expand your VPN capacity and resolve bandwidth challenges and set people up without creating new cybersecurity problems. Teams had to learn to use the remote capabilities built into their automation systems and codecs. The story played out across radio. One director of engineering told me he's been pushing for years to get his company to give more people laptops and allow more working from home, but the bosses resisted it. And then on that one Friday in the middle of March that we all remember, the head of the company announced, well, we're sending everyone home, and on Monday, engineering and IT will have everyone set up. And he went to the boss afterward and said, have you lost your mind? But they made it happen. It was about solving problems all across radio. NPR's Tiny Desk series switched to performances from musicians' homes. In our Radio World webcast just this week, Jason Ornelas of Bonneville told me about how his team created these standard remote kits very quickly that had portable mixers in an SKB case for the people in the field who then would open it up and be able to control RCS Zeta automation remotely. And what Bonneville did, the cluster, was they gave simple training videos to the staff along with those kits to show them how to plug it all together very simply at home and make it work. So there's a really great story here on how technical teams have responded and how radio's learning from the experience and how radio works to stay live and local, because we all know that's when radio is best. And with so many team members stuck at home, that was hard. But this is when people most want to hear a real person and voices they know. Of course, the story is not all rosy. Unfortunately, in addition to the health pandemic, we've seen more layoffs in our industry recently, which had already seen quite a bit in recent months, now made worse by the business downturn. And we've seen headlines about job furloughs and executive pay cuts. Well, what happens when we all go back? That's one other story we'll be following. Will we all go back? It'll be interesting to find out, is this the death of the open office and gathering areas like the ones we see there? What happens to offices that are full of cubicle farms? Do we just put up plexiglass shields between work areas and try to spread people out? We can certainly expect more frequent high visibility cleaning and sanitizers for hands everywhere and tons more teleworking. But I think it's safe to say that radio has accelerated its reliance on the cloud and working over VPN and using software solutions. One engineer told me he doubts he'll ever build the same kind of big broadcast facility that we're accustomed to. He thinks the station of the future is smaller and that many people, at least the non-air talent, will work from home with a plant focused mostly on showcase studios and on executive offices, if that. There's some other stories we expected to cover heading into NAB, and I'll just mention these very briefly. All digital on AM. The FCC has heard from the industry, and now we're waiting to learn if it will allow stations to operate in all digital on AM. You'll hear more about that from Dave and Mike in a moment, but I'll just say that my money is on getting a yes from the FCC. It'll be interesting to see if more stations make that change. Asymmetric sidebands. The use of FM IBOC asymmetric sidebands mode has been proposed, meaning FM HD stations in the United States would be allowed to increase their digital power on just one side of the signal. It currently requires an experimental authorization. Several organizations, including the NAB, Xperi, and NPR, have asked the FCC with a petition to allow routine authorization of that. New operation modes. HD radio allows for a number of modes, and NAB has recently investigated MP11, which until recently was not supported by most transmission and reception equipment. Compared to the standard hybrid HD radio modes currently used by most broadcasters, MP11 adds more digital sidebands, and it offers an additional 25 kilobits per second of capacity. Manufacturers are now implementing this. Hybrid radio is poised to be of growing importance. Here, the term refers to those emerging platforms that combine over-the-air broadcast reception with online connectivity, extending the station's impact beyond the over-the-air footprint using audio streaming. Hybrid will bring enhanced metadata and listener interactivity. It'll give broadcasters more analytic feedback about listening. One example of a platform like this is the 360L system that was recently announced by SiriusXM. But hybrid radio comes with a drawback for local US broadcasters, and this is where this next idea, broadcast-only zones, comes in. The problem is that once a driver tunes to a station, a hybrid receiver may silently stay connected to the streaming audio signal to support time alignment for seamless switching back and forth. But that means that the streaming signal is in use even when the receiver is playing the RF feed and no one's listening to the streaming. That means performance rights go way up for broadcasters. So the NAB is looking for a fix on this, trying to come up with an approach by which a broadcaster would provide a description of a strong signal area in which streaming is not allowed, and the receiver would know by location information where it was. It can detect the position of the car and tune only to the broadcast signals within a certain area. But this is only a proposal at this point, and it may be a challenge to convince car makers to implement it because of cost and complexity. Briefly, other items on the agenda: LPFM rules recently updated. There's some new technical rules for low power FM stations, including the use of directional antennas in certain circumstances. No big game changers in that order, but some technical details of interest to those who are active in LPFM or have one locally. The radio in-car user experience is just something we're all going to have to learn to think about constantly, and we can expect more discussion about that. The North American Broadcasters Association is working on a set of guidelines regarding the design of the automobile user interface to try to advocate and standardize the way radio appears in the dashboard. There was going to be a panel about this at the NAB show. Xperi, NAB, and the associations, the broadcast associations in Canada and Mexico, were going to take part. So that's a story we'll continue to follow. Cloud and virtualization, I mentioned that already, but we expect an acceleration of the uptake of those technologies. Oh, and happy anniversary radio, 100 years this November. the beginning of the modern commercial radio industry, though as many of us in this meeting today know, radio actually had many beginnings if you go back to all the technologies that brought it to KDKA going on the air. So Radio World is celebrating that with a series of articles this year from our history experts, James O'Neill and John Schneider. Now, before I end, one thing I sincerely regret about not being in Las Vegas for the show every year is that we could not present our annual Excellence in Engineering Award, which we announce each winter and present each spring. Nautel has kindly allowed me to take one more minute here to celebrate our recipient, and he's a friend of Nautel's. He's Dave Kolesar, the senior broadcast engineer at Hubbard Radio, and we recognize him for his initiative in converting WWFD Frederick, Maryland to full-time all-digital transmission, the first AM station of its kind in the United States, and beyond that, for advancing our industry's discussion and awareness of the potential uses of the MA3 mode. You know, it's exactly the kind of thing that this discussion today, where Dave is joining you on the NUG. So, Dave, congratulations.
Thank you very much. It's quite an honor to be to receive this recognition from Radio World, and I feel very fortunate that an idea that came to me around Christmas time 2016 came to fruition, and now it's even a regulatory push.
Well, you've got a lot of interesting things to talk about. And yes, there is in fact an award. Here it is. I'm sorry that I can't hand it to you. I'll have to accept it virtually. Let's see if I can line it up there. And then the next time we're able to crawl out of our burrows, I'll hand it to you. But before I go, I just wanted to ask you quickly what you're thinking about. What's going to happen in the next few months with this? Is the FCC going to allow all digital on AM, and do you think stations will jump on it?
Well, I certainly hope they'll allow all digital on AM. I have a feeling, if I were to bet, as you said, I would say that yes, they will allow it, because otherwise they probably wouldn't have pulled the proposal into an NPRM so quickly if they hadn't at least seriously considered the possibility of allowing it. And as far as stations converting, there are a number of stations who are interested right now. Of course, we don't know what's going to happen with the economy right now and how that might affect people's plans. But on the other hand, I think some broadcasters will see this as an opportunity to change the way they do business, and maybe digital AM might be a part of that.
Well, again, congratulations, and I know you'll stay on now to continue the discussion, but that'll wrap it up for me, other than to congratulate Nautel on its annual NUG and its record turnout today. Jeff, if you hit that last slide for me, and I'll turn things back to you. And I just want to add to Jeff Welton, congratulations, this year's NAB Radio Engineering Achievement Award honoree, Jeff Welton.
Thanks so much for that, Paul. It really was both a surprise and an honor. It seems that this is one of the few industries where you can really get recognized for running around sharing whatever you know. And we'll talk about that. Shane Toven did have a comment on the questions, and forgive me for looking away from the camera as I read it, but I'm pretty sure it was on hybrid radio from the looks of it. Talking about a listening flag to get sent back to the broadcaster for their logs when the receiver's actively using the stream, because of course, as we know, there'd be challenges with rights and who gets paid how much. So that was an interesting comment. Just something to jot a note down there about. David, and we've got Mike Raide here as well from Expiry, and we're going to do a little discussion about the all AM IBOC MA3 mode. It is recently been up for comment. There's been a lot of comments back and forth in both directions. Hybrid AM has been around for quite a while, jokingly called adjacent channel, because the digital carriers do go a little further away from the fundamental of the analog frequency. David, did you guys run hybrid before you ran MA3? You did, right?
No, WWFD was not a hybrid station. Our sister station, what was then WTOP AM, was, but WWFD was never hybrid. So it was in bad shape before we got a hold of it to do the digital conversion. So it never would have passed hybrid, but but it might be able to now, but we're doing all digital, which is better.
Right. And so just clicking over to all digital, the one thing that really caught my eye was that it does bring the sidebands in a lot.
Yes, it does. And I think, Mike, you want to tell us a bit about that?
Yep. So what happens is we go from 15 kilohertz plus and minus from the center frequency to plus and minus 10 of the center frequency. Also, there is more power in the digital sidebands now, certainly in the primary carriers, where in the old MA1 system, or the current MA1, I shouldn't say old, but in the current MA1 system, the primary carriers are at minus 10 to minus 15 and plus 10 to plus 15 out, where now the primaries are brought in plus and minus 5. And the secondary and tertiary carriers, as you can see there in blue, are the outer carriers now. With the MA1, the primary carriers were 27 dB below the center unmodulated carrier, which represents just over 0.2% of total power. You can see the disadvantage there. Whereas now with the pilot carrier in MA3, that represents 37% of the total power. The rest of the total power is in the digital sidebands, marking a huge difference.
So that means obviously a significant increase, even with square law, that's going to be a big increase in coverage. And we've got a coverage map up there, so we'll talk to it in a bit. But Dave, what have you guys seen with coverage area relative to the analog? And I mean, I know, again, where you didn't have an MA1, I know you can't compare to that, but with the analog, how you doing?
Compared to analog, we're doing quite well. In fact, we seem to have gained some coverage, at least gained some useful coverage, whereas when the analog was scratchy and your average listener would tune out, the corresponding digital signal now is, of course, loud, clear, no static, no noise, and to the average listener, they'll probably hang on to the signal longer than they were before.
Yeah, I definitely would agree with that. When we did some of the drive testing for Xperi, anybody who's familiar with the Washington D.C. area around the Beltway, there was only one place where WWFD was lost, and that was going over the American Legion Bridge, which crosses over the Potomac into Virginia. So there's a bit of a dip of a valley there, but the entire Beltway was covered by the core-only carriers.
Right, and it should be noted that where WWFD's transmitters, we're talking about a 4.3 kilowatt station 30 miles away from the Beltway.
Right, at its farthest point, it's almost 40 miles. The 210 across the National Harbor is the furthest point away, and that's 41 miles, air miles.
Now, one thing that you guys were doing, are you still doing it virtually? You had a paper for the BEITC this year, correct?
Yes, we'll be recording a video very soon to present.
Excellent. Now, I did happen to get a sneak preview of that, and it was pretty interesting. And one of the slides from it was this one. So can you tell me what we're looking at?
Sure, yeah. I guess this slide here concerns the PDM modulator within the transmitter. And what we have is we have two transmitters at the station, a main and an auxiliary. On the left, you see the auxiliary. On the right, you see a main, which is a Nautel NX5. And of course, the pulse duration modulator is what controls it. On a digital signal, the two inputs to the transmitter are amplitude and phase. Amplitude goes into the audio, magnitude and phase, and the magnitude goes into the audio input of the transmitter, which of course is controlled by the PD, which is of course is turned into RF by the PDM modulator. The phase input goes to the external oscillator input. And here we see the effects of inadequate PDM sampling rate upon different components of the MA3 carriers. On the top left in the aux transmitter are the 64 QAM primary carriers. They are distinctly formed, but note the cloudiness of the constellation. In the middle are the PIDS carriers, which contain the basic metadata and fast acquisition information, which allows the receiver to quickly decode MA3 audio within a second and a half, since there's no analog fallback. Since these carriers are distorted, receivers don't lock to within the predicted time frame. And looking at the secondary and tertiary carriers on the bottom left, they look like noise or garbage. As a result, the only data making it to receivers are the first 20 kilobits of the primary carriers when we use the aux transmitter. It should be noted that these transmission errors cause self-interference, leading to increased sideband noise as well. So while the aux transmitter is still compliant with the NRSC2 emissions mask, it exceeds NRSC 5. Now, taking a look at the set of carriers, the signal constellation on the right, when the PDM rate is high enough, as with the NX5 transmitter, all the MA3 carriers are clean. Looking at the top, look at how tight the constellation is compared to the aux transmitter. The PIDS carriers just below, as well as the secondary and tertiary carriers on the bottom right, they're also very well formed. Even though these ones are the most affected by crest factor reduction techniques and antenna bandwidth issues. And with the commission of the NX5 transmitter spring of last year, we're now transmitting the full MA3 mode at 40.2 kilobits. And that allows for full stereo audio, artist experience, and most importantly to us, fast receiver acquisition. We found this to be the most beneficial development, as listeners can now find the station by tuning around and not having to wait 5 to 6 seconds for the receiver to lock without those fast acquisition carriers. And of course, it's likely not a coincidence that the first Nielsen book that encompassed this change yielded the first appearance by the station in that book in approximately 15 years. So we think it made a big difference.
Interesting. No, we did talk a little bit, and you guys were together yesterday for a little bit of test and measurement too. But I know we talked about the coverage area in general, and you said overall it seems to be pretty solid. Yes.
Yes. Drive tests do provide a good insight to how well the signal carries out and how solid reception is. And in general, we found that the full MA3 waveform is received down to the 0.5 millivolt daytime contour, at which point the receiver will blend to just the primary or the core carriers, which reduces the data rate from 40.2 to 20 kilobits per second. Artist experience is dropped in this fringe area, and audio reverts to either mono, or if you're running it, as we just started last month, parametric stereo within the core carriers. Under ideal circumstances, the core-only signal can be received to the station's 0.1 millivolt daytime contour, 0.1. But critical hours propagation phenomena, of course, may reduce this. And I should note that within the 2 millivolt contour, the signal was nearly impossible to break in spite of noise, obstructions, bridges, power lines. We just couldn't break the signal. Thunderstorms too. So, and it's not shown here on the slide, but I do want to talk about night coverage for a second, because I'm sure that's a question that everybody will have. At night, there is one map that should be drawn up, and that's the station's half NIF contour. The nighttime interference-free, or NIF contour, is a calculation that predicts the core service area of an AM station at night. For WWFD, this value is calculated to be 10.8 millivolts, for example. The half NIF contour is therefore 5.4 millivolts. It's within this contour that in the times of the worst co-channel skywave interference, no degradation to our signal was observed. So this defines the minimum limit of marketable coverage. It should be noted that at pattern change, when we switched night pattern, reception was often observed all the way out to our nighttime half millivolt ground wave contour, and that coverage retreated as the evening progressed, sometimes all the way back to the half NIF. So that's what's been our experience at night.
Good. So it's useful information. Now, one other thing, and I don't have a slide for it, but I'll hit it real quick before we go to the next one. You'd mentioned this before in our talks, and it's a valid point, and I've used it for FMHD a lot, is processing.
Yes. If you're processing an all digital AM signal, you should process it just like you would an HD2 or an HD3 or a low bitrate internet stream. You don't want to apply the same processing philosophies that you would to an analog AM signal. Density is not your friend. You want to leave.
Yeah, asymmetrical modulation certainly is not your friend. Yeah, you don't want to.
Yeah. So you want to process it as if you're processing a low bitrate stream. And you want to give the codec room to work because you are dealing with 40.2 kilobits.
Right.
That's not a lot, but as anybody who's played around with processing streams knows, you can do quite a lot with it and make it sound quite respectable and quite good, in fact. So much so that the average listener has been comparing it to the quality of an analog FM signal, and I would tend to agree. In fact, I would say that the end result is better than an analog FM signal because you don't deal with the pre-emphasis, and which has always been a little annoying to me.
Understood. Okay, now hit the bear in the room. We're going to put Mike on the hot seat a little bit with this next slide. So HD2 on AM, tell me about it.
Okay, well, Dave and I, we had been actually at Xperi, been kicking this around to say, was it possible? We knew that it was in baseband chip receiver code. Some code it's there, or some chips it's there, some chips it's not, but it was always a possibility. And so with the receiver team and the broadcast development team came up with a configuration for the new Gen 4 importer, which we're using out at WWFD, which is a Nautel multicast plus. Putting in that new configuration, we were able to do this on December of 2019 for pretty much for an entire day. Dave chooses to run the WWFD with just the HD1. He's not necessarily looking for HD2. He obliged us by allowing us to test this. But
the way the test
possible.
plan works is that Mike calls me one morning and says, "Hey, let's do an HD2 on AM," and I'm like, "Sure, why not?"
It's pretty much how it worked out. Because we had talked about it internally at Xperi, and literally hit Dave over the head with it one afternoon and said, "Yeah, let's go out to Frederick and play around some mud." So
beats working.
So what you're seeing, yeah, that's right. So what you're seeing here is on a test receiver. The upper left picture is the PSD. So it's broadcasting on the HD2, the sister station, which Frederick WWFD is a relay point for 103.9, their FM for WTOP. And to get the audio up to the transmitter site at 103.9, they have to do a double hop. So 820 is a jumping point. So we had the audio source for WTOP and WFED in real time. So we were able to use that in the importer. We put in the new configuration. We turned on an HD2 audio client, And what you see on the bottom right is the artist experience, which was the station logo for WTOP. So not only can you do artist experience for the HD1, but you can do it for the HD2. You have the PSD information. It behaves just exactly like an HD2 on an FM.
Okay, now I'm going to step back. We've got a few questions that have come in, and I know you guys are wrapped up, and I don't know if you're going to hang around for the end of it. So we'll hit your questions right now. I've got a request from John Hardy asking about just explain a little more about crest factor reduction, if you could.
Oh, sure. Briefly, crest factor reduction is a way to improve the available headroom in the transmitter. So the MA3 waveform has a peak to average power ratio of 9.8 dB. Standard AM modulation has a ratio of 6 dB. Now, with crest factor reduction, it basically shapes the signal such that you do not need as much amplifier headroom. And I believe within the NX5 transmitter, the crest factor reduction reduces the peak to average power ratio from 9.8 down to about 8.2 dB. In the NX5 transmitter, our average power is 4.3 kilowatts, but the peak power can be somewhere in the neighborhood of 28 kilowatts.
Right, that's the huge difference between MA1 and MA3, because you said it earlier, Jeff. You're cramming so much more power, channel power, into that area, and the nature of 64 QAM is very peak driven. There's a lot of peaks, and the amplifier has to have that headroom to do it. So in the transmitter that doesn't have crest factor reduction, you would have to reduce the amount of power to allow that headroom, the amplifier to have that headroom to be able to transmit that peak power.
Well,
otherwise it gets clipped and it turns into noise. You go back to that constellation pattern where it's just all fuzz.
Right, and I'll jump in with one other thing there. The other thing is you've got to look and convert that to peak voltage for a lot of marginally designed directional arrays. So hitting some of them with 5 kilowatts MA3 could be an issue.
We had to upgrade a few capacitors in our array.
Yeah. We went from micas to vacuums in a couple instances. Yeah.
All right, I'm going to step backwards. Vaughn Taylor had a question, and this would be more for Mike. If there's any interest in all digital for 9 kilohertz markets, and what similarities to DRM. Vaughn's down in South Africa. Technically, I don't see any reason why you couldn't do it, but talk to that a little bit if you could, Mike.
Yeah, we've internally at Xperi discussed about 9 kilohertz markets. In particular, right now we are testing our FM system in India. The government has expressed some interest in 9 kilohertz AM, even though they are licensed for DRM. They have not totally dismissed us and would like to see it testing at some future time. I know DRM has been tested in South Africa. We have not, but we certainly would look forward to the opportunity.
Okay, very good. One last question on this, and I'll let you guys go. Ed Delaney wanted to know how MA3 compared to analog with respect to power consumption. Shouldn't be any significant impact on the power bill, would there?
Yeah, actually none at all. In fact, an engineer from the FCC contacted me a number of months ago in preparation for the NPRM and asked me whether or not we've noticed any change in power consumption. So I went and I had our accounting department pull the past couple years worth of bills, electric bills, and our electric usage and our cost of operations have not changed at all. Now, that being said, I'll say that being a 4.3 kilowatt station, we were not using MDCL. So the apples to apples comparison is between a transmitter that's not running MDCL and a transmitter running MA3. You cannot run, there's no such thing as MDCL for all digital operations.
Right, obviously, and
Right.
I'll
Yep.
talk about that in a moment too. So
Yep, and
okay.
one other thing to touch on that too is with the HD2 testing, and you're talking about MDCL. One of the things Xperi is looking into the following coming up year, even with COVID-19, we anticipate testing new MA3 where the unmodulated carrier is reduced by a certain measure, and also elevating the enhanced carriers a certain amount as well, probably another 6 dB, just to see how, one, it would perform, how the transmitters would handle it, and two, how the receivers would handle it. So there are new things and modes we have coming down the pipe. So
Very
I
cool.
would just tell everybody, stay tuned.
Okay, excellent. Well, Mike, Dave, thank you both very much for your time, for spending so much time with us. We went a little over, and I really appreciate the information. Thank you.
Thank you. Really appreciate you having us.
Thank you.
All right, now I got so eager when we got started with this that I skipped ahead of a whole bunch of housekeeping stuff that you probably really should see. I see that most people have figured out how to ask questions already, but if you haven't seen it, there is a question icon on the control panel, and as I see the questions popping up in the window, I am trying to hit them. Anything we don't have a chance to hit in the next little bit, we will do in the process of via email after the fact. Also, this will be archived, so as I said, we will run long. If anybody has to jump out, totally understand, no hard feelings, and we'll be getting a link out to the archive version in a week or so. So just a quick look at where we are going. Obviously, we've done the first three topics. We'll hit MDCL. Everybody's looking at when we're getting rid of Flash. We'll be doing a little demo with Matt, talk about some HD multicast, a little bit about a new product, LookingGlass, that you may have seen and heard of. And if we've got time, some tips and tricks. If we don't, then maybe I'll just record those and you can all go home. We'll do them in the archive version. Who knows? All right, carrying on. So back to where we were. Let's see there. So MDCL, we talked about it a little bit in the session just with the MA3, and my short description is it's intentional carrier shift. What you're doing is analyzing the peak output of your AM signal, and depending on the algorithm, either increasing or reducing the carrier and the audio level appropriately. On average, with the least aggressive form of MDCL, you tend to see a decrease in the power bill of about 25%. On a 5 kilowatt station, that may not be so much. On a 10 or 20 kilowatt station, it starts to get significant. There is a calculator on our website where you can figure this stuff out and get a good idea on to how much you could save per year, break it down per month or whatever. So just as an example, in this one, I use a 10 kilowatt, looking at 50% efficiency, probably a tube transmitter, going to an NX and then adding MDCL. And you can see it's an additional $4,000 a month, or a year, sorry, you'd save on power. Might as well go in your pocket as the power companies. Oh, as I said, there are different algorithms. AMC is one of the most common, and the way it works is as the peak power goes up, as the audio hits a positive peak, it reduces the overall signal, so compression. The 3 dB is the most typical, which is what you see here. So you can see you're at about 50% power at 100% modulation. Okay, there's lots of information on our website about that. If you go to the website and there's a little search bar, just type in MDCL, you'll see a bunch of articles there as well. So pros and cons of it, definitely a big power savings. Something else a lot of people don't tend to think about is if you drop the peak power, you drop the peak voltage, which means if, as I was talking about earlier, you're running in an aging antenna system, you're putting less stress on the antenna system components. It can have an impact on range and signal quality, although most folks with the AMC3 say that that's undiscernible. They can't measure it or detect it. And depending on your algorithm, you could increase your peak voltage instead of decreasing it. So you do need to pay attention to that sort of thing. Now, here's the one that everybody's been waiting for. And I know Matt's been chomping at the bit. We're already a little bit behind. This is hardly a surprise for a NUG. But so I'm going to welcome Matt Herden from our product support, development, marketing. Matt wears many, many, many hats. And I'm going to let Matt talk to these slides. But what we're looking at, if I'm not mistaken, is the what do you call it? The guideline of the new AUI.
1 second. I think I got some slides I want you to show, so I should not be showing my screen.
No, I've got this.
Okay. I can't see the slides, so.
All right.
I'm going to stop showing my screen. Someone handed it to me, so I took it.
All right. Yeah. No, I will hand it to you for the
demo.
For the demo. Exactly.
Thank you.
So let me go back to the GoToWebinar and make it. Oh, shoot. Now Ed's throwing chat at me. He's just totally botched it. Show my screen. Here we go. All right.
There we go.
Are we good now?
Yes, we are.
Good. Holy smokes.
Thanks, Jeff.
My pleasure.
So we've got some pretty high goals for this, and other than the obvious, and I'm not going to say the F word, and that was to make the transition to this new world as easy as possible, and that involves making it familiar, making it usable, so it's quick to learn. It needs to be secure because we live in a new world where security is even more important than it ever has been. Obviously, we're making a big investment in this, and we want it to last a long time, so a long life. Everyone's been hoping to see a mobile-friendly AUI for a long, long time, and so that was very important. And of course, we have to support all our transmitters. So those are the goals we set for ourselves. In general, what's new is kind of everything. So the AUI itself is a common AUI code base, if you like, for everything that we have. It's written in HTML5, and it uses the very latest UI technology to give us that long life that we're looking for. Some of the technology that's in there has only really reached maturity in the last 2 or 3 years. So we're right in a very an excellent place for doing the best possible user experience on HTML5 in browsers. Everything runs in a browser, so you don't need apps. It just runs in a browser. And but what you probably don't know is that underneath all of this, there's going to be a new operating system for your transmitter and kind of everything in between. So that's pretty important because it allows us to put this new technology onto your transmitter. So which transmitters? It's all of them. Anything that has an AUI on it today will get an upgrade to move to that all the way back to the first with NV, but the full length and breadth of our transmitter series that you have, plus any future transmitters. We're investing heavily into something that we can use for a good long time. What does it look like? So it doesn't really change the model. We're still going to run the AUI from your transmitter. So if you have a GV or an NX and you have a front panel AUI, then you'll be able to, then you'll have a touch screen on the front, the same touch screen, and it'll just run a new user interface. If you're at the site, you want to connect through Ethernet, through your local area network or whatever, you can have your laptop and you can fire up the AUI locally and of course remotely. So if you set it up to operate through the internet, the app, the web app itself that runs in the browser is what we call responsive. So it will run on a desktop, tablet, phone, all of those good things. So
very good. Now, at this point, I'm going to hand it over to you to do a live demo. This is where you get full control of the screen and everything. One quick question that's come in, the new operating system, is it totally self-built or what's it based on and how much downtime to install it?
that we're going to share a little bit later. It's a different OS, or it's slightly different OS depending on the actual series you're talking about, so it's not one size fits all. Obviously, some of the transmitters are harder to do than others, but we'll supply an installable. It'll be an install package that we keep the upgrade process as simple as possible.
Very good. And at this point, I'll switch it over and you can take care of the demo, and let's rock and roll.
Thank you. I'll wait to get control.
I'm waiting to see if Ed does it. There we go.
There we go. We're going to share that one. Can you see that?
Yep, it's good here.
Okay, cool. Okay, so this is the new AUI, and I think one of the things that jumps out for me is the fact that it's actually pretty familiar. The layout is something that is not a shock or a nasty surprise for someone who's familiar with the existing AUI. And that's truly one of our goals, is familiarity but also usability. To introduce this, you can see that we've got the spectrum is taking up the space on the left, and then we've got 2 on the other side. I call this the 1 plus 2. If I change my zoom level after clicking on the right window, we can see that it automatically adjusts to show what I call the 1 plus 4. And this is an example of how the responsive design works. As the size of the screen changes, it accommodates, and you can pick whichever zoom levels you want to do. The data that's running behind this is our QA data, so it's meant to represent a lot of different use cases. So don't try and understand why some screens are doing strange things and shouldn't be, and it doesn't match. That's normal. Starting from the top down, along the top, we've got our header bar, and which includes our and also then moving down, we come to the status bar, and the status bar is what you're familiar with from using the current AUI as well. So things like forward power, reflected power, temperature, and so on, they're all listed there. Typical high visibility status bar. For those people, and not naming any names, Jeff, that are not familiar with the icons that we've chosen to use, we have hover tips. So everything will sort of explain itself as you use it. That's an intent to make it as usable as possible. Down in the bottom here, we could go ahead and choose the content of any of the screen areas, and that allows you to customize this the way you want it to be, and it'll be remembered for you. The local and remote indicator is off onto the left. We have the RF on and off buttons here. I'm not going to do those. Those are a little laggy when I'm demoing like this. So, but the next step we're going to take a look at, because time is of the essence, are the alarms. So we're going to jump over to the alarms. Here, if there are alarms you don't really want to pay attention to, you can go ahead and click on them, and you can just hide them. The indicator will tell you that they're hidden, and you can bring them back if you want to. One of the things that's very handy to have accessible to you is the alarm history. So there's a shortcut to jump over to the alarm history, which is on our reports page. And we could go ahead and download a report, and you'll see down in the bottom left-hand corner, I hope, the CSV file that has been stored on my local hard drive. I could open that up, do some further analysis, etc. We're not going to go through the other broadcast reports and so on in the interest of time. So we're just going to keep moving. I'm going to introduce the menu very quickly. So you'll find that the language we've used here in the menu is very familiar. It's a lot like the one that you have on the current AUI. So there's things like meters, presets, reports, audio player, remote IO, etc. I've made the beta sign up link live on the AUI page, and you can see the URL there. the other thing, if you're hearing me, is we'll also do an in-depth AUI webinar sometime soon. So stay tuned for that. We'll announce it on the AUI page as well.
So Matt, thank you very much. I really do appreciate your time. We're going to step over to Alex now and see if Alex is around and available. Alex, are you there? So carrying on, we next thing up, you have joined the fold, so to speak, and come over to the dark side. Welcome aboard, glad to have you on. And you've been playing, in addition to doing your customer service work, you've been playing a little bit with Philip in engineering, and you've been tinkering with the HD multicast.
Yeah, they gave me the keys to the kingdom and they let me break it.
We may live to regret that, folks. We'll see where it goes. As you can tell, Alex is in his home office, and I said the only thing he needed was have an episode of Frozen or something playing on the other monitor behind him.
It's on that one.
But we've got pretty good attendance. We don't want to mess that up. So on the HD multicast, tell me what I'm looking at here.
This is a coverage map of New Hampshire Public Radio, where they contacted us looking for a method to, hold on while I adjust my headphone, where they wanted to minimize impact in adding HD 2s and 3s to 5 of their signals. And of course we obliged, and we had figured out a way that our platform with the Multicast Plus is capable of scaling. So we were able to load it with several copies of the importer software to accommodate this to feed several exporters out of the same unit.
This is one of the cool things with having the Multicast Plus over some of the other ones. The thing has got so much horsepower in it that you can add a bunch of things and still not run out of steam. So how much processor power are you using with this particular setup?
About 25% of the machine's capable power. So it's still got a little bit of room to wiggle.
So tell me what you're running.
So it's several Linux instances running in a VirtualBox system to keep each individual piece away from each other, so that we treat it as if you had 5 separate pieces of hardware. The common goal here was that we have the audio inputs, since they were going for a common HD 2 and 3 across all 5 signals, we only needed the 2 stereo audio inputs to feed all 5. So, and they're a WheatNet facility, so we've certified the Multicast Plus product with audio over IP from Wheatstone, Axia, and Dante as well. So you're on your own to plug it in, but it supports it. We can now do that by just replicating the audio channels. When you replicate those audio channels, it takes a lot less headroom, obviously, to create something like this, where we are now distributing that to several test sites, and our transmitter actually in the lab there in Halifax is also getting a copy just for verification of the process.
Now, one more thing that we don't have shown here, because this is geared for where you're distributing audio from a TOC from a central location.
Correct.
One of the things we don't mention is that depending on your network connection, you could, for example, have an EAS receiver at one of the remote locations getting alerts for that county, dump that audio back to your TOC to have it embedded on the importer feed specifically for that station.
Correct.
Or
So,
local content insertion.
Or local content insertion, or name your slice of pie however you want to deal with it. Because it is a centralized based system, it fits nicely with New Hampshire Public Radio's future vision for their technology. And they have expressed interest in even growing this a little bit more. So we're working with them on how well that will scale and how to implement that in the future going forward within their facility.
Aaron Reed over at Rhode Island Public Radio is, sorry, Aaron, is busy in the questions. I think he's got a system pretty much built out already. So you may be getting a phone call shortly after this session.
I was actually looking over to see if it was ringing already. But
now,
yes, Aaron, I'll call you, don't worry.
So one of the other things you've been able to do with this is and there's a shot of your desktop if I'm not mistaken, but
Correct.
you've been able to load all the PID stuff, the album art and stuff like that, right?
Yep, it is doing metadata. So we've got PSD data, we've got artist experience in there, all controlled through the web UI system there you see on the screen. It's treated as, in this instance, 6 separate systems running on the same piece of hardware. For New Hampshire Public Radio's instance, they are a Wheatstone facility. As such, they're processing their audio external to this. So the processed audio comes in over the WheatNet driver, and then it's disseminated from there.
Okay, and Iris asked what the NHPR timeframe was for implementation, and if I'm not mistaken, it was about 2 days ago.
2 days ago. They've got 3 sites online right now, and they're working on the rest. Obviously, with the COVID thing, it's a little harder for them to travel around and get everything implemented and fitting into our time schedule as well. So, because as they turn up each individual one, they're having us go in and handhold a little bit to explain the process to do that, so that they know how to implement it further.
Right, right. And Dave Reitner was asking, does this mean you can feed HD 2 and 3 to all the sites with only one HD multicast unit? The answer is yes, that's exactly what it means. Dave Ewell wants to know, his multicast is running Windows 10. Is it possible to retrofit with Linux? And there was a reason for not doing that.
Correct. As a lot of people know, we live in a Windows world. As such, specifically for the audio over IP implementation, as far as I know, only Livewire has a Linux implemented driver that's available from a third party, not directly from Axia. So we had to kind of keep this in the Windows world because of the compatibility with also the Lynx audio card has no Linux drivers, nor does the Orban inside processor cards. So the base host has to stay Windows. The underlying importer implementation, however, is running Linux.
So it's basically Windows on a Linux core.
Correct.
Now, the other cool thing, and I don't remember if we'd talked about that earlier or not, but no, and Ira's telling me Keen is not online yet, one of the NHPR sites. He's monitoring it as we speak. So there you go. Anyway, you're running instances of WheatNet to drive NHPR, correct?
Correct.
But it wouldn't have to be any specific audio over IP system.
No, the nice thing about this, and in this process, we've actually, and I have kind of taken the reins on, audio over IP has always been a big thing in my wheelhouse. I think it's the greatest thing since sliced bread as far as the studio facility is concerned. It takes a lot of the guesswork out of the wiring nightmare behind you, as you can see. But the ability to use an Axia driver, a WheatNet driver, or a Dante driver has always been a question for a lot of Nautel customers, specifically relating to HD. As such, yes, the HD multicast is AOIP compatible.
And that was one of the questions that Shane Toven had just asked was, have we tested Dante? So there you go.
Yes, you can.
And Kevin's making sarcastic comments about the two of us on screen together, but that's a whole different story.
No later hosing, guys, sorry.
Yeah, that comment was already up there too. So on this screen, we're just looking at all the audio clients, correct?
Correct. So again, to keep the systems equal but separate is that everybody knows the Gen 4 screen. You see it right here. Just think of this as running 6 separate instances of that same software to keep each other happy. So there are 5 instances of the Gen 4 control panel running, 1 for each importer instance. So it's just running an audio client only mode. And this is also where you set up your MSAC for your artist experience as well. That part did not change. The only thing that's not here is the actual importer configuration that lives in the Linux side.
Right, right. And speaking of artist experience, we've got a shot of the fully loaded NHPR system.
Correct. And again, this is screenshots from an Innovonics Sophia we have in the lab in Halifax. So this is coming out of their TOC in New Hampshire and going right across the public internet, right into our into an Exporter Plus and to an X-Gen on a VS300 and a VS HD, and picked up over the air. So this is in the real world.
Right. Now, one question Shane had was how scalable is an approach like this? How few or how many? Obviously, we can go down as low as one. How many could you load without feeling that you're jeopardizing the processing power?
Right now, that question's still up in the air. 6 seems to be a really good point. I think I could comfortably say 10 without having any other things running on the system. Wouldn't be, I think that would be a comfortable overhead limit with our current hardware platform.
Okay, and Mike Tosh is asking if the Dante implementation is native Dante or just plain AES67 compatible.
Whatever you buy from Dante, that's what I used in this lab to certify it. So I just used their reference driver right from their website.
Very good. And do you know if NHPR has a backup distribution system?
I do not know. I do know that their primary HD1 and FM is sent over satellite. So they've got an uplink downlink system that they pay for, and the HD2s and 3s will all use I believe they're working on fiber interconnects to each site to do all the rest of it. But right now this is running on like a DSL line, a cable modem, whatever they have available in the wherever those sites are.
All right. And Kevin, now that he's done picking on us, has got a serious question. Can I install my Axia driver on the HDMC Plus using the spare NIC card for the Axia LAN and transmit the E2X data on the other port?
How do you think this is working, Kevin?
The answer is yes.
That was the key to this, was that the multicast Plus does have dual networks. So one is internet facing, one is studio facing.
All right. At this point, we're going to switch over to the next topic, and you get to stay here for that too, because the next topic is one that's very near and dear to your heart, LookingGlass.
Yes, my baby.
Little caveat, I got to play with LookingGlass before LookingGlass was even a thing. That's, I think, 4 or 5 years ago, looking at a laptop in the trunk of your SUV in the KFAI parking lot in Minnesota.
Yep. That was when Jeff saw it, and he's like, "Uh-oh."
I can see where it can be a lot of fun, and we've recently acquired that from you, which makes it even better for you to be one of our partners, because free support. Well, free is relative. Now, what are we looking at here? I mean, we're going to have to cut the time up because we're already over, but let's see what we got.
And we do have a dedicated webinar on this product coming up here in a couple of days. So
we'll put that in a second.
Yep. So this is the main screen of LookingGlass. This is the full band FM spectrum. It does look out 25 megahertz. So it gets you a little bit above and below to see if you're falling out of band, but we call it a band scope because you can't call it a spectrum analyzer. There's rules there. So it's a band scope of looking at what the signal noise ratio is, and that's the entire FM band at once in 60 frames a second.
All right, digging in a little further, then what?
Each one of these, you can have up to 30 demodded channels out of the entire FM band. Here's what it drills down into. Here's what one station looks like: RDS data, modulation numbers, RF spectrum, oscilloscope, baseband, all configurable. Custom names. This will do live wire in and out, so you can use it for off-air monitoring in an AOIP facility. So use it as an off-air monitor.
Now, it also does recording, if I'm not mistaken.
It'll record audio and RF. It will record the entire FM band at once. So you can now have a snapshot in time of the entire RF spectrum. So if you missed an event, say something happened, you want to go backwards in time and look at that, you can record it and then put it in play mode, and it will play back the entire FM band.
Very cool.
At the RF level. So it's manipulatable at the RF level.
Excellent. Now what?
This is what St. Cloud, Minnesota looks like with all the modulation going at the same time. You can see a couple of them there aren't tuned, but a handful of them are. So this is you can see it over my shoulder here, running right now. That is all active modulation in real time.
Very cool. And then you get to all the meters.
Then you get to all the meters. Here's the oh wow factor. So our top screen there is all the live RDS data, which, by the way, this does record your RDS data and spits it out in a CSV file for you. And it will hold that data for, I believe, 60 days still. So you can log all your RDS data. So you got our affidavit information if you're selling your RDS to clients, or if you need to go back and do song list, or just want to see what everybody else is playing. It will hold that. Below that, you got RF-SNR, and it is a true signal to noise ratio. We do measure from the base of the noise to the peak of the signal, not just a reference. So it constantly moves around. MPX power, for those of you in the world that have to abide by the ITU rules for MPX power levels. And then below that, on the left-hand side at the bottom there, is ITU 1770 loudness. So there's your LKFS and LUFS metering, and of course the modulation. And when you start adding up 30 of them, it gets really small. I have a 50-inch monitor right over my head that I need to actually read them all.
There you go. Wait till you get to be my age and have to look this way to see anything. Now, Dave Reitner had a good question, and it might be a potential development direction for you. Could you use it in a mobile environment and drive around to get an idea of signal coverage over a given area?
That was on the original roadmap when I developed the product, and still is. We just need to get the legs underneath it to get to that point.
And Ira wanted to know, it is using SDR technology under the hood, I assume. Correct.
It is a very it's a custom SDR load on a off-the-shelf SDR that allows us to do this. All the heavy lifting is actually done completely in software. I'm literally taking just the raw bandwidth right off the chip into the software at this point.
Now, and the questions come up a couple of times before, is there a plan down the road to make a smaller scale version, one that, say, I have a smaller market, only 4 or 5 stations, or I only want to look at the 4 or 5 stations of my own in a given market?
Yes, again, was on the roadmap. We just had to get some legs underneath it, and with the partnership here with Nautel, I hope that we can accomplish that.
Very, very good. How much space does it use per minute while recording to hard drive?
95 megabytes per second.
There you go, Sean. All right. Well, thank you very much. As we said, there is a full-blown webinar coming up on this a week from tomorrow. I think folks that tune into that will be stuck with you and me again. So yep. I'm not sure if that's a good thing or a bad thing.
Answer the next question that everybody's going to ask, it doesn't do HD yet. It sees it, but it can't decode it yet. Give me time.
There you go. That's a good question. Okay, well, thank you very much, Alex. I will look forward to doing this webinar next week with you, and I think we're going to have a lot of fun.
All right, sounds good, guys.
All right, on that note, wouldn't be right if we didn't do a few tips. We're going to keep it down to a bare minimum. We're already 15 minutes over time. Obviously, more and more we're working alone because they tell us we have to. So make sure you play safe out there. And use the time to do some maintenance out at the transmitter site. This is one of my favorite pictures just for the tower fence. Anyway, so do some maintenance. Transmitter sites, the ultimate in social distancing. Document, document, document. This is my scribble on top. The customer sent me the plan view of their site, and I started drawing notes on what I figured we should change and adapt. And they incorporated that into their notes, but at least that way you've got a full deal. And yes, Aaron, no, to skip back, there was no fence, just a gate, but the gate's still standing. Anyway, that has since been fixed, by the way. They've got new owners, and they've been looking after that site quite a bit. Thermal scans. One thing about thermal scans, I've talked about these thermal imaging cameras a lot. Everybody's, I think, that's seen me talk has seen my little FLIR 1 thermal imaging camera, and it works really, really great. One thing to note is that the readings can be different depending on whether or not the surface is reflective or not. And infrared cameras, as a rule, will work like that, and a reflective surface will show a different reading. If you want more accuracy, use something like non-reflective cloth tape, hockey tape. Of course, the Canadian thinks of hockey tape for just about everything. You know, it's almost like duct tape up here. Anyway, something like that. If you put it on the areas, you'll have a consistent place to point and shoot for getting constant temperature readings over and over. That way you can see a trend before it actually happens. One other thing, last night, I took a look at some codecs. There's a lot of stuff still visible out on the internet. Folks, don't leave the keys in the lock. If people can see your device, then it's a target for hacking. Now, if you've got a hard to guess password, then maybe it won't get broken into, maybe it will. But a VPN or something where they can't see it at all is always a good idea. Okay, so definitely, and pay the extra bucks. Like, you can get a good VPN. I use TunnelBear. I think it's like $30 a year for the fully unlocked version with no limits and everything. One other thing is a lot of situations happen when somebody brings some material in on a USB stick to play on their show, plug it into a production computer, and the next thing you know, you've got a full-scale virus or malware situation. So one cool idea is have a sacrificial machine in the lobby. They bring in something to use on their show, they stop, they plug it in, they scan it, and if it passes, then it can go into the production room. Something like that. Air gaps always work best. If something's not plugged into something else, you can't have an issue with it. Okay, I'm going to close with this little thought. I don't remember what brand of shampoo specifically it was, had the I'll tell two friends and they'll tell two friends and so on and so on. I know I'm showing my age here, but everybody listening knows something that somebody else doesn't. Find that person, share it with them, whether it's mentoring through the SPE or other programs, whether it's via social media, whether it's writing articles or industry trade shows, whatever you do, share whatever knowledge you've got as much as you can. Until then, stay safe, be healthy. Thank you very, very much for attending. Hopefully we'll see you in Vegas next year. Bye now.